So if anyone has worked on any of the products like Power Center or IDQ, it will be pretty easy for them to grasp it, because basically MDM is solely UI based, so we don't have to code much. It's only the configuration part where we have to configure all the things, which comprises of MDM Hub, IDD, that is the Informatica Data Director, and HM Hierarchy Manager. So this is the course content, which starts with, which is having around 13 to 14 modules. It starts with the introduction to the MDM Hub, and after that we have already a model defined, which is near about real, but what we do in the real time with all the customers and their addresses. So real time, whatever modeling, it is a scenario of that. So already a model is defined, and which we will be working on, and there is a lab guide which tells about step by step what are the steps that needs to be followed to recreate those into the MDM or configure those into the MDM. So it is mostly practical. So for after every module we have labs that we needs to be done, and server access will be provided so that you can open this MDM console into your local, and then you can do all the development and configuration work. So that's the basically all the comprising of 13 modules, including the MDM as well as the other component, which is the Informatica Data Director and the Hierarchy Management. So, and this is basically the lab guide. So after every module, we need to do the lab guides, and it is self-sufficient basically, because it tells step by step what are the things that needs to be done. So coming to the introduction part of the MDM. So like, as you know, Informatica MDM is like, there are a lot of MDMs that are available in the market, but Informatica MDM is the leader in the master data management. And you can see that a lot of openings are also there in the Informatica MDM. So to start with, like, we'll discuss about the initially like what is a master data, and then why basically we require MDM or the master data management. So master data, as you know, that master data is very core data or very critical data which uniquely identifies a customer across various systems. Like master data might consist of names, addresses, date of birth, license numbers, etc., as well as related data like zip code, phone numbers, and other components of the addresses. So master data basically plays a very critical role in information management. But when we deal with master data, there are a lot of challenges that we face when we deal with the master data. The first challenge that we face, like the master data or the reference data, we can say, is often household, and it is managed across disparate systems. So there is no single system of record which a company has. There are multiple systems, and all of them are maintained separately. So, and naturally we know that the data changes over a period of time. The data has a life of its own, which keeps on changing. Like we move or add house, we can change the mobile numbers, email addresses. Similarly, like in case of business, there are a lot of restructures and acquisitions are happening. So basically the data has a life of its own, and it keeps on changing. Secondly, the data is not maintained at a central location, it is maintained separately. So if you take a very example of a like a company which is having like production and sales department, like production department in we can pick like purchase and sales. Like the purchase department is there, which is maintaining separate information of all the purchases that it is doing from a particular customer or the company. Similarly, the sales department is maintaining all the information of all the sales that it is making to a particular customer or organization. So both the data it is maintaining separately. So there might be some organization or a person who is both purchasing and selling the products to that particular company. So his information is maintained in both the location. And it's also that it might be the application that is used to store all the data is different, and also the structure, basically the data model of both of them will be different. So at a later point of time, when the company tries thinks that it wants to consolidate all its customers, whether it is in the sales department or the purchase department, and create a central repository of the records to know that what are the customers it has. At that point, it faces this challenge because data, as you know, is never correct in the systems. There will be some differences in the data, like that when basically the typing errors or mismatches which we usually see in the data. So when the company tries to merge the data, it's very difficult to identify that this person is exactly the same person, because even a little change in name or address might result in a different person. And also there are a lot of persons with the same name. So it's very difficult to identify whether this person which exists in both the places are exactly the same person or he is a different person. And there, as we discussed, the data changes over a time. So in some places the address might be different, or the older address which is not updated. So similarly, there might be many other scenarios. So it's become very difficult for a company to consolidate the records or to identify that this is the same person or this he resides on this particular address. So at this time, basically master data or the MDM comes into picture, and MDM helps the company to consolidate the records. So it will get the data from all the source systems, like the, for example, the one we discussed, purchase and the sales, and it will help to consolidate the record. It will help to identify that these two basically which exist in both the systems are basically the same person or he is a different person, and try to consolidate the record and create a single view of the record. So once this consolidated or the central repository is created, which in MDM terms we call as a best version of truth, or a BVT in a short we say. So then the company knows that it has a central repository of the records which can be trusted upon. So the names, their addresses, whatever other details are there, those are correct details and it can be trusted upon. So once it consolidates the record, it can be consumed by the downstream systems as well as the source systems from where it got the data. So the purchase and the sales department from where it got the data, it will pass the data to those source systems also, so that they can update the data into their place. So throughout the enterprise, we will have a consistent view of the data. Anywhere, even if it is maintained separately, the data will be same across the enterprise. So that is basically the main purpose of MDM, or the master data management, to consolidate the records which is coming from a different systems and create a single view of all the records. So in MDM we have that fuzzy logic which basically helps to identify the closest matches between the records. So it takes into variation some differences between the record based on the whatever settings we do, and on based on those settings, it helps to identify that these record, basically these customer data, if it is there, like these customers are the same person or it is a different person. So that's the main part here in MDM, which is the match and merge rules. Other than that, we have this normal cleansing activity that we usually do. So this is an example of how the consolidation process works. This is not exact example, but I will just tell you the scenarios because here there might be some differences in the data. So in this example, basically it is trying to tell us that how basically the consolidation process happens. So here, for example, in this slide, three source systems are taken into consideration, like Duns and Bradstreet is their call center and billing. So these are the three source systems from which we are getting the data, and we have to consolidate the data and create a master record. So as you can see, we have address data. Address data is coming from all the three systems, whereas there are some other columns also. So now the business has to take into consideration that what are the columns it wants to take and create a master record. So we'll leave other things as such. We'll just discuss about the address, like we are getting address data from the three source systems and we have to consolidate that. So now during this consolidation process, there is a feature which is called as a trust and validation, which comes into picture. Trust, basically we have to configure in MDM as per the business, because if you see we have this address data, address, city, state, country and postal code. These we are getting from all the three systems. So if we are getting data from multiple systems, we will not be sure like which data is the correct data and which data should be promoted into the master record. So to ensure that, we have to provide trust in the sense that which is more trusted, and that basically is given by the business, because the business knows the data better and the business can tell us that which source system you can trust for each and every column. So the trust is applied on a column level. So like we have these three systems, so the business will tell us that, for example, for the address you trust billing system more than this call center and then the Duns and Bradstreet. So business will come up with this and then we will give it a number in MDM. So number is like from 0 to 100. We can give any number. That is just for MDM to know that it is more trusted system. So for example, if we give like billing as 90, call center as 80, and Duns and Bradstreet as 70. So when the MDM identifies that these records are duplicate records and they needs to be merged, at that time MDM will see that there is a record from billing system, so it will trust it more. So this record will always get promoted into the master data. So it will have a preference over other systems because the trust factor is more for the billing system. Similarly, if I have only two records, one record from Duns and one from call center, then call center will be given more preference because it has more trust than the Duns. So this basically comes into picture when we try to merge two records or consolidate the records. So first of all, what we do in MDM, we take all the source system records like these three systems. We will insert all the data into our MDM, and then we basically create match rules that on what column basis we want to identify that these are duplicate records. So based on that, MDM comes up with that. Like for example, here we have the first one. If we see Madison Eve, so these first of all the three, it will show as a duplicate record, and they needs to be merged to create a single repository or a single record. So at that time, this trust comes into picture. So while merging the record, MDM will check which is the more trusted, and it will give preference over other source system. So this value will always get promoted into the base object or the master record basically. The second thing is validation rules, which comes with the trust. Validation we have to apply because even the trusted system might send wrong data. For example, we know that the city or the state cannot be null. So if we are getting this value like city or state as null, we can downgrade the trust. So that's a feature which is the validation, which is used to downgrade the trust of a particular source system. So we will do a check, like for example, if the state is null, downgrade it by some percentage. So for example, we had given billing as 90%, and we will downgrade it by, for example, uh, we downgrade it by 50% or 50. So this value will go down to 40. So now when the records MDM identifies, for example, this record, the call center record and the billing record as a match, and we need to merge those records. At that time, because this state is coming as null, it will downgrade it. So for billing system, the trust will be like 40, whereas for call center, it is still 80. So the call center data will get promoted into the base object or the master record. So that is basically a feature which is called as trust and validation that we apply on all the columns. Basically, it is on a column level. And when we merge the records, it comes into effect, and it will see which is the more trusted system. It will promote that into the master record. Whereas the one which is not promoted will still be there in the, basically there is XRF table which maintains all the history for records that are coming from a source system. It will be maintained there, but in the master record we will have only one record.
Hi Vinay, Chandan.
Yeah, hi, yes, Sri.
Sorry, the names was Sri, but my name is Chandan. Actually, I have a doubt here. Like you said, validation. Uh, so is it like uh,
Sorry, your voice is breaking. Can you come again?
you said validation, right?
Yes,
Trust and validation. So
yes,
if
yes.
trust happens for each individual record, or for example, if for a particular load, if there are 1 million records coming up, so is the trust and validation which gets applied for each individual record, or for the entire set of records, it decides like this much percentage?
No, it is on a every record level basis. So like for example, in this case MDM identifies that the first record of billing, the first record of call center and the first record of DUNS, these three are duplicate records and they needs to be merged. So when we merge, basically we have three records, but when we merge all these records we will have only one record. So while merging these records, this trust comes into picture. So whatever are the matched record, for that it performs this trust and validation, and whichever is the highest one, it will promote that into the master record. So it like we have to check like what are the columns, like the address, city, state. These are coming from more than one source system. If it is coming from more than one source system, then only we need to apply the trust, because we are not sure that which is the correct record. If the data is coming from only a single system, then we don't need to provide trust, because I know that this data is coming from only a single system. I have to insert it anywhere into the base object. But because if it is coming from different systems, we are not very sure that which data will be correct data. So for that reason, we provide this trust. So business basically gives us this uh, feature, tells us that which is more trusted. So they might have many systems from which we are getting the data, and they will tell us that which system you have to trust more for each and every column. So I have this address like 6 columns. So for all the columns, I will check with business that which system should I trust more. So business will come up with that you trust this system more than the other systems. So based on that, we just give it a number in MDM so that MDM knows that this is more trusted.
Okay, so
So
is it like for every load, if for example, if there are some 100K records or 1K records, so for the conflicts and all, we get back to the business, or will there be any process which is defined in the first place? Like I mean to say, whatever you said, like the percentages, trust and all, initially would be given by business, and again
yes,
we will get back to the business. That is what you're
yes, again the business has to come, because what happens uh, here, like business will tell us that which is the more trusted system. So based on that, I just gave it a number in MDM. Now when we define the match process, based on the match process, like I gave like you match based on these columns like company name, address, cities, state, country, and postal code. So I gave these 5 columns for the matching purpose. So based on these columns, MDM will identify which are the duplicate records. So for example, MDM identified that the first record of all the 3 systems are duplicate records and they needs to be merged. So there are 2 things, one is auto merge and one is manual. If we have defined auto merge, then in that case it will merge all the records automatically, and while merging the records it will take into consideration the trust factor. So it will see which is more trusted system. So the trusted system value will always get promoted into the master record. So
Okay.
if I have the billing system which is more trusted, this value will always get promoted into the master record, and
Okay.
other source system will not get promoted. So only one condition is there: the other source system value will get promoted only when the for the main system the validation fails. Like for example, that we discussed, if the column value is coming as null, or if the, for example, the postal code, it is, we know that postal code should be like only 5 characters, it cannot be less than or more than 5 characters. In those cases we will downgrade the trust. So if the trust is downgraded, obviously that other source system value will win over this. So in this case, if we downgrade the trust of the billing system, then the value from the call center will get promoted into the master record, otherwise it never gets promoted. So that's why we use this trust and the validation.
Okay, so for automatic
Okay, quick question.
hello.
Yes, tell me.
Yeah, Vinay. So for automated process also, as you said, like there might be conflicts. So everything, there could be a chance that we might get conflicts, and also again that those will be recorded somewhere, and then we'll get back to the business with the queries, right? That is how it happens, right? In real time.
Yes, like I told, the 2 things are there. One is manual merge and auto merge happens. So for the auto merge, we all we would have been doing testing on it. So we are very sure that once any record matches on this rule, is always a correct match. So whatever merge happen is always correct. So we don't get back to business for that. The other thing is the manual one. So once the record gets matched, we give it to the business that MDM has matched these 3 records. So now the business will look into that and it will identify whether this match which has happened in MDM is correct or not. So if they feel that yes, this match is correct, they have a UI that basically used IDD. So there they can see that when I merge all these records, which will be promoted into the master record. So for example, if they feel that something else should be promoted, for example, if you say uh, for example, this postal code is given here, and this postal code has to be promoted into the master record. But if he feels that no, this postal code is wrong, he can edit the data, or if he feels that some other value should get promoted, he can promote that data. So it is on business basically. When it is manual, it is based business. The data stewards or the business analyst looks into those and he decides that which value should get promoted into the master record.
Okay, okay, and got it.
Okay, thank you. Then this is the architecture of the MDM. It is same like 3-level architecture. On the top we have the UI client, or we also called as a hub console in MDM, which comprises of like many different consoles. Like we have data steward consoles, which data consoles which contains tools for the data stewards so that they can uh, log into the MDM and they can do some data manipulation activities like creating, updating, matching and merging of the records. Then we have this admin console, which is for the administrators who will be like creating the users, assigning the roles and the accesses. And basically in MDM the admin is not very vast, so we as a developers only do all this admin related stuffs, like configuring all the users and then assigning the permission roles and the permissions. And then we have this designer console, which is the main part where we configure all the objects into the MDM, like all the tables, relationships, lookups, everything is configured in the design console. And we have hierarchy manager console, which is like if you want to see data in a graphical format or basically a tree structure, that we can configure in the HM console or hierarchy manager console. So basically, like if you want to see, like organization is there, we want to see what with this organization, how many customers are associated or employees are working in that organization. So it will show in a tree structure or binary tree structure. We can say that on the top it will just show the organization name, and then it will link all the customers or the employees it has. So that is basically useful for the business or basically the salespersons who want to view the data in a graphical format. So that's the basically the UI layer. And then the application we have in the middle layer as the application server, which is like as of now MDM supports 3 application server, which is JBoss, WebLogic, and WebSphere. So basically 3 application servers are used, and mostly the companies uses JBoss as an application server. And then we have a database server. So basically 3 databases are supported as of now, which is Oracle, DB2, and SQL Server. So we will discuss more about these application server and the database server in the next slides. So just for an overview, that basically 3 application servers and 3 database servers are supported as of now by Informatica MDM. So this is basically the application server architecture. So here this is the external client or external applications. So external applications can be like IDD, which is the Informatica Data Director, which is used mostly. Otherwise, it can be any external client. So those external clients can use these communication protocols. We have these 3 protocols that are supported, which is web services, messaging queues, and EJVs. So using these protocols and these APIs, like a lot of APIs are provided. For example, these cleanse for cleansing the data, match for matching, put is for creating a record, update, and there are a lot of other APIs which are provided. So they can use these communication protocols to fire these APIs, so that they have to code their in their basically application. But if you are using IDD or Informatica Data Director, you don't have to do any coding, because these APIs are fired automatically when we do anything like updating a record or creating a record. These APIs gets fired automatically, so we don't have to code anything as such. But if the client is not using IDD, they want to use their application, then they will have to use these communication protocols and fire these APIs. So once any request is fired, it comes to the MDM Hub server, where we have defined all the data access and authorization, which is based on a role. So in MDM, we create different roles as like data stewards, data managers roles will be there, and we will be giving them access on a column by column level basis. So there are on the column level basis, plus there are many accesses, that is the create, update, delete, merge, execute privileges. So based on the business requirements, we give them access. So once any request is fired, it comes to the hub server. It basically checks whether this user is having access to fire that particular request or not. So if it doesn't have access, it will throw an error that you don't have sufficient privileges to fire that request. And if the user is having access to fire that request, it will go down to the application server, where we have this MRM server, or it is called as a master reference server. So from hub server, it gets directed to this master reference server, and the master reference server basically checks what are the client servers that are available with MDM. So usually what happens in the real time, we usually have one hub server which will be installed in one system, and then we have multiple client server which will be installed. So whenever a request comes from the hub server to the client server, it will just check what are the different client servers that are available, and it is just pass the request to those client servers. So it basically works as a load balancer in MDM. Any request that comes, it will pass to the client servers, which will process all the requests. It will communicate to the database server. It will process the request, and it will return back to the clients or the external client. So that's the basically architecture of this application server. Any user that fires any APIs, it comes to the hub server where the access is checked, and once the MDM knows that this user is having access, it passes the request to the application server, where it goes to the MRM server or the master reference server, and then MRM server checks that what are the different cleanse and match servers that are available. This is basically internal. When we install this MDM software, it comes with this hub server and cleanse server. So these all cleanse and match server, master reference and hierarchy, these all are residing in the application server layer. So first it comes to the MRM server, which acts as a load balancer, and it will pass the request to whatever all the cleanse servers that are available, which will communicate to the database server, process the request, and it will return the results back to the external client or external application. And this is the database server architecture. So like in Oracle, we have a sys and system user, and which maintains information about all the other schemas that we create in the Oracle. This is a similar concept here. Like once we install this Informatica database, it comes with two things. One is the system schema, which contains the ORS connection information. ORS is basically a short form of operational research store. So like in Informatica MDM, we don't call it as a schema or user, we call it term as a ORS or operational research store. So this system schema maintains these informations like the ORS connection information, the user ORS permission, which user is having access on which of the ORS, the tools permission, like we saw the different tools are there, like the data steward tool, the admin tool, the HM tool. So whichever tools we have given access, those tools informations are maintained in the system schema. And then we have this ORS schema or the operational research store. So when we create this ORS schema, with that there are some 60 to 70 tables gets created, which are basically the repository tables, which maintain all the metadata information. So when we create anything from the MDM side, UI side, like creating a table, columns, or creating the relationships, the lookups, or the mappings. So for everything, there is a repository table which contains the information that this change has happened on the MDM UI layer. So we can have multiple ORS or the operational research store, and this can be registered with the system schema. Once we register it, we will be able to use those ORS for the development purpose. So that was the application server architecture and the database architecture. And the last, like we will see the data flow into the MDM, that how the data flows into the MDM and goes out of the MDM. So here in this example, it has taken into consideration two sources, like data source 1 and data source 2. So in MDM, like we have the landing table, So landing table is basically called as an entry point for data into the MDM. This table we create from the MDM side only, and this table basically doesn't have any constraints as such. All the columns are nullable columns because we don't want any record to be rejected while loading into the landing tables, MDM landing table. Any record which can should be rejected, it might be because of duplicate record or some other issues, it should be rejected by the MDM itself, not before that. So that's why this landing table is a nullable table where the data load happens from the source system. So the loading data into the landing table is external to MDM. It is not controlled by the MDM. So we can use any tool that is available in the market to load the data from a particular source system into our MDM landing tables. So the source can have different database. Like it might be like, for example, if you are using Oracle, the source might be some other like Salesforce, DB2, SQL Server, or any file system format. So we can use some tool like Power Center is mostly used for converting the data into a particular format and loading it into the tables. Or if it is just Oracle only, you can use like SQL Loader or DB-Link to load the data. So that's an external process. We can use any tool to convert our data and load into our landing tables. So once the data is loaded into the landing table, then basically the MDM processing starts. So the next process is basically the stage process in MDM. So now in the stage process, we have staging tables. So once between the landing table and the staging table, we will have a mapping defined that what columns from the landing table will be mapped to the staging table columns. Just 1 minute. Yeah. Hi. So between the landing table and staging table, we have a mapping defined where we put that what are the columns from the landing table will be mapped to the staging table, and also like whatever the cleansing requirements we have, cleansing and the validation part, we do all the steps here itself between the landing and the staging table. For example, a basic cleansing requirement that we have to, like, general column is there and we are getting the columns as 0M, male, female, MF, and we have to standardize the data into like M and F. So that's a basic data cleansing or data standardization is there. So whatever data cleansing and data standardization are there, we do here between the landing tables and the staging table in the mappings. So once we load the data from the landing table to the staging table, we know that all the data is a cleansed data here in MDM. And then with the staging tables, like when we create a staging table, there are few repository tables or supporting tables gets created. Like we have this reject table. So a reject table basically stores all the rejections that happened during the loading the data from my landing table to my staging table. So rejections might happen, as I told, like in the landing table we don't have any constraint, but in the staging table we have two constraints. One is like the primary key column and the other is the last update date column. So primary key column can be basically has populated from the landing table. So it can be a single column, like it depends on the again on the business. If the business says that, for example, you can use customer ID column as a primary key, I can just pass the customer ID into the primary key column. Or if the business says that I want to use customer ID and, for example, customer type as a primary key, I will concate those two columns and pass that into the primary key. So we should ensure that the primary key column is always populated because it is a not null column, and if we are getting null data, it will get rejected while loading the data. Similarly, we have the last update date column. Last update date basically has to be populated from the landing table, and this is provided by the source itself. And we can say that this is source last update date because when the data was created in the source or when it was last updated in the source. Basically, the source system sends that date. So that date we populate into the last update date column. So these two are mandatory columns, and in case we don't populate it, the records will get rejected. Similarly, this is the first level of duplication that we remove based on primary key. So for example, if we have customer ID 1 coming 2 times, then the first customer ID 1 will get inserted into the staging table, and the second customer ID 1 will get rejected, that this is a duplicate record. So all this, and there are other rejections. So all those rejections will go and sit in this reject table. So we can go there and check. We have a reject with every staging table. We will have a reject table where we can go and check which records have been rejected and what is the reason for rejections of those records. Similarly, we have a raw table. A raw table is basically used for auditing purpose. Auditing in the sense like first time we loaded some, for example, loaded some 100 records from my landing table to the staging table. Next time when we load the data, we usually truncate the table. We truncate the landing table and load fresh data into this. So at a later point of time, if you want to know that what record has been loaded into MDM on a particular date, we can use this raw table to find that. So we can go there and we can check based on, it stores data based on a date field. So we can go and check that on a particular date which records have been loaded into the MDM. And similarly, there is a more table which is called as the PRL table or previous landing table in MDM. So that is basically used for delta detection. So delta detection, as you know, that it will detect delta records. So how it works basically is like, for example, first time we loaded some 100 records from a landing table to the staging table. So that table will contain all those 100 records. Next time when we truncate the landing table and for example we loaded fresh data and again run the stage process, at that time it will compare the landing table and that PRL table or the previous landing table, and it will check whether any of the data has been loaded previously or not. If it finds that the data has been loaded previously, it will skip that data and it will process only the new or the changed records. So this is helpful sometimes when we are loading a lot of records, because usually the records will be in millions which is being loaded. So if at an initial level only we identify that these records were already loaded and skip those records, we will save some time in processing the data, because between the landing and the staging table a lot of cleansing and validation happens for the data. So if we detect the delta records and skip those while loading into the staging table, we will save some time. So basically time gain will be there in between the landing table and the staging table. So these are the basically three tables which are associated with the staging, that we have raw table, reject table, and the other one is the PRL or the previous landing table used for the delta detection. So once the data
Hi,
comes
Vinay.
into the, yes.
Uh, like you said, landing table is always a truncated load, like every time the previous data would be truncated.
Yes.
In staging table, will we have the entire data? For all the loads, the data would be there in staging table?
No, no. Staging table is also truncate and load. So every time we run the staging process, which loads the data from landing to the staging, it truncates the staging table and then load the data.
Okay, so I mean, I have a doubt. Like you said, raw will with raw. You said like the data delta detection will happen, right?
No, there is another table which is called as a PRL table. It is not here in this slide. So that is PRL or previous landing table. So that basically helps to detect the delta records. So in this case, for example, usually we truncate the table, but for example, we loaded the record for the first time and then we didn't truncated the landing table. We added some new records into the landing table and ran the staging process again. So in that case, it will compare the landing table and the PRL table or the previous landing table, and it will know that these 100 records were already loaded previously. So it will skip those 100 records and it will only process the new records.
Okay. So the previous landing table, whatever you said, it will have only for the earlier loading means the previous
Yes,
data, or
only only the previous run. That is a restriction basically. Only the last run. It will not for all the runs. Only for the last run. If in the last run it was a particular record was loaded, then only it will skip that record. Otherwise, it will not skip.
okay. Sorry, I just missed out on the raw. What kind of information would be there in the raw tables?
Raw is basically just a copy of the landing table. So from the landing table, all the records will get copied into the raw table. So as I told, like usually we truncate the table. So at a later point of time, if the business wants to know that which records were loaded into the MDM on a particular date, in
Okay.
that case we can go to the raw table and check, because it keeps the data based on a particular date. Like on this date, these many records were loaded.
Okay.
So it will be easy for us to go and check in the raw table, like I loaded these records on a particular date into my MDM.
So it will have all the data. It is not like
Yes,
a load information. It have all the data,
yes,
right?
it has all the data. Raw has all the data based on a particular date.
Okay. Okay. Got it. Thank you.
Okay, thanks.
Question. So which of the tables will move to the next level? The raw is just like the landing table. The rejected table is also the bad ones.
Yes,
And you said the previous load
previous,
table,
yes,
that's just
PRL,
for comparison to help you with the delta load. So
yes.
which table or which data is moving to the next level in the MDM?
Yeah, it is the staging table. So basically, like when we create a staging table, it has these supporting tables. So basically, the raw table, reject table, and the PRL table are the supporting tables for the staging table. So this staging table will go to the next table. So this data, uh, when we run the load process, the next process is basically called as a load process. So when we run the load process, it copies all the data from my staging table to the final target data model, or the final base object, we say final table or final base object in MDM. So like for example, here in this we have address. So I have an address table. So from staging table, the data will directly get inserted into the address table. So
Oh, okay. So the cleansing, the cleansing and um, some algorithms of processes goes through from the landing tables to the staging. The cleansing and all those things happen. So when it gets to the staging, it has already been refined.
yes,
Is
correct.
that correct? Okay.
Yeah, correct.
Thank you.
Thanks. So now, like,
Yeah.
yes, tell me.
Sorry to interrupt you.
No, no.
Uh, uh, for example, here in this example, we can see two sources. So for two sources, for example, let's say for the source one, we have got 10 tables, and source two, we have 20 tables. So how many landing tables and how many staging tables are required? Is there any,
Yes, yes, landing table, basically we usually have one per base object. Like for example, I have address. So for address, I will have only one landing table. And usually what we do, for example, if we have two source system, for example, so I will create a single landing table, and in that landing table, I will add an extra column as source system. So in that column, I will populate that this data belongs to source 1 and source 2. So landing table we usually have only one, but staging table there is a restriction that the staging table has to be created with number of source systems. So if I have two source systems, I will create two staging tables.
okay.
So that is the restriction for a staging table, but for landing table we usually create only one landing table and just add an extra column as source system and populate the data there in that table, that it belongs to source 1 or it belongs to source 2.
So so if you have 100 data coming from data source 1, 100 from data source 2, you're going to have
Yes,
200 records in the landing table.
yes, correct.
Okay. Thank you.
Thanks. So now, for example, I have my two source system. So I loaded data from my source 1 into the data from source 2 into my this staging table. So I have two staging tables. I loaded data into both of the staging table. Now, when I run the load process, so it will load the data from both the staging table into my target data model, that for example the final table or the final base object in MDM, which is the address. So for example, we will take into consideration like I loaded only a single record. So I loaded one record from my source system 1, I loaded one record from source system 2. So in my address table, I will have two records from both the source systems. So now with this, when we create address table or the address base object, with that there are like 10 to 12 supporting tables which gets created. So which maintains information about like history information, the trust score, the matching part, or the XREF detail, the validation part. And there is one important table which is called as an XREF or cross reference, which is basically used to identify by MDM that the incoming record is basically a new record which is coming into the MDM, or it is an update that is coming for a particular record. So that's an important table which is called as a cross reference, and it is associated with all the tables. So in this case, what happens, for example, I loaded two records into my address table. So now the next process is the match process. I will create match rules to identify, basically I will define the columns based on which MDM has to identify the duplicate records. So suppose that when I run the match process, MDM identifies that these two records which I loaded from one from source 1 and the other from source 2 are duplicate record, and they needs to be merged into each other. So that's basically a match. So this is the match. When we run the match process, MDM will identify the duplicate records, and then we have two options. Either I can auto merge the records, means whatever records got matched, I can merge those records automatically, or I can just leave it as it is, which is called as a manual merge. So auto merge we usually do when we are very sure, or we can say 100% sure that whatever records are getting matched are exact correct match, and when it merges it, the final consolidated value is always correct. So if we are very sure about that, means we must have tested it thoroughly. So we will be very sure that yes, any record which is matching and getting merged is always correct. Then we make it as auto merge. But if we are not very sure that the records that are getting matched is always correct, then we leave it as manual. So in this case, the data stewards will come into picture. He will look into the data and he will identify whether these records which are matching is a correct or it's not correct. So if they feel that the records which have matched is correct, he can merge those records. And if he feels that with the records which are matched with each other are not correct, then he can reject that match. So that basically is done by the data stewards or the business analysts who have the knowledge of the data, so they can look into the data and they can identify that whether this is a correct match or not. And if they feel it is correct, they can merge the data and create a consolidated record into the MDM, or they can just reject that data that no, this is not correct match. So maybe in the next time we can take up those rows again for matching purpose. So what happens, for example, the data steward identifies that the two records are duplicate and they have to merge. So he will merge those two records. So what happens in my target data model or the final table, I will have only one record. Because initially when I loaded the data, I have two records. But when I merged those two records into a single record, I will have only one record in my base object. But in the XREF table, this is the XREF table, it will have still two records, because XREF maintains a type of history that two records have come into the MDM and finally it got merged and it is like single record into the base object. Because the base object.
So when they are merged, when those two records are merged into one, they all have their own keys coming from the different data sources. Now, when they are merged, is it going to have another key, and then it's going to have like a mapping, like two different sources mapped into this particular record?
Yes,
Is
correct.
there a
So
way to track it?
yes, we can track those. So basically what happens when I load the data, in my xref table I will have two records, and in my address table I will have two records. So when I run the merge process, what happens, one record is deleted, basically because those two records are merged into each other. So based on the trust and validation, MDM will now see which is the more trusted column, and it will promote all those columns into the base object or the target data model. So in the address table, I will have only one record, but in the xref table, I will have still two records, which will show that these two records, one record came from source system 1, one record came from source system 2, and there will be a column which will tell you that these two records have merged into each other. So if you go to
Oh,
this,
okay.
if
Okay.
you go to this particular table, you can easily identify that these two records have merged into each other, and that's why there is a single record into my base object.
Okay.
So similarly, like if you unmerge those records, now for example you merge those records, and in your address table you have only one record, but you feel that no, the merge that I did is not a correct one, so you can unmerge it again. If you unmerge it again in your base object, you will have two records. So again the one record which was deleted will come back again into your address table. So again you will have two records there. So that is basically the merge process and the unmerge process. Merge will delete that one record, unmerge will put back that record again into the base object. So everything can be tracked. There is history tables will be there, the xref table is there, and there is a separate table which is used for only matching and merging. So we can go to that table also, and we can check what are the records that have matched, or sorry, which records have been merged or unmerged. So there are a lot of supporting tables are there, useful tables which we can just query and get all these details.
Hi, Vinay, this is
Okay.
Gayatri.
Yeah, yes,
Uh,
Kat.
so in a real-time data warehouse BI system,
Yes.
so where would the master data model, the target data model that I see in the slide, so where would that ideally sit in the real time? So would that form or would that be in the source pipeline of a data warehouse BI system, or would that be some kind of lookup that I do while I'm loading into my data warehouse? So I'm trying to understand how it works in conjunction with a data warehouse.
No, basically like the data first comes to MDM. Here we
Okay.
consolidate the data, and once it is consolidated, then we pass this data to the data warehouses.
So
So
this will be the
previously,
source, this will be the kind of the source for a data warehouse
yeah,
BI system.
yes, yes, correct. So previously what was happening, the data from a source system was directly getting passed to the data warehouses. So now
Okay.
they are not passing directly to the warehouses. They are first putting that into the MDM. They are consolidating the records and creating a master record, and then this data is getting passed to the data warehouses. So
Okay.
that's the
Okay.
change basically.
Okay. Thanks.
Okay, thanks.
Okay. So in a data warehouse project, do we have like say two models, like one model which is going to be used for a model to create a master data, and we also have a model for the entire warehouse. Say you are using dimensional modeling or whatever, you can have a model for your warehouse and a model for master data, or master data doesn't really need a model since you can create everything in the Informatica MDM. Or can you create it separately using like Erwin?
No, we cannot create it separately. Like we have to basically, for example, initially you can do the normal ER modeling in the Erwin or any modeling tool, because it's a just initially like when it happens it will start with modeling as usual, which is like ER model will be defined that these are the objects that we are going to create and these are the relationships. Just we need to convert that into the MDM format, because in MDM like relationships are defined in a different way. So just we need to convert that ER model into the MDM model. So that's a little bit change will be there, but we cannot like just import that file into the MDM. We will have to create it manually, like we will be creating all the objects manually, like the customer table, address table. We will create all those things, and then we will create the relationship that this customer is having this address. So for that, we will have a separate relationship table. So it can be like when we go next, we will see like different types of relationship, and for every type of relationship there is a separate configuration. If it is one-to-one, we configure it separately. If it is like many-to-many relationship between the base objects, we will configure it separately. So it's the same ER modeling.
Oh, okay.
It's the same process, means whatever initial level ER modeling that we do, we will have that thing only, but just we need to convert that into the MDM format. So just little bit changes will be there in that.
The ER model will just be used as a guide, but all the models has to be created again in the Informatica MDM. There is no API or any way third party way you can import into MDM. Never.
Yes, that we cannot do. Like import is not possible. So initially, like when the business basically comes up with the ER model, and once the ER model is finalized, then we just convert that into the MDM model. And then everything we have to do from the MDM side only. When once we do from MDM, we can uh, in MDM only we have a data model which gets created, which we can see. So I will show you that, please.
Okay.
So like this,
Hi,
it happens.
Vinay,
So
one last question.
yes, tell me.
So I see in the consumer section there's an application that's listed on the slide. So by application you mean it could be a reporting system as well, is it? So can I run reports directly from my MDM database?
Yes, well, like in MDM we can use Jasper reports.
Okay, so
now
if I have business objects, so can my business objects engine read or build reports from the MDM database?
yes, it can directly read the reports from MDM database.
Oh, okay. Okay.
And like in MDM, like we use Jasper reports. So based on the business requirement, we will create the Jasper reporting, and then we use that to display in the IDD application. So Informatica Data Directory is there. So in that we use display all the graphs basically.
Oh, okay. Okay, thanks.
Thanks. So once the records are consolidated, then we basically get the consolidated record or the master record. So this record is usually send it back to the source system. So this record we usually send it back to the source, like the source 1 and source 2, so that they update the data into their system. Also it is passed to the other consuming systems. So basically in MDM we use messaging queues. So if any communication that happens through the messaging queues, whether it is consumed by the downstream systems or the upstream systems. In MDM we configure message queues that based on like what changes, like when any record is updated, deleted, or created, matched, merged. For everything we can configure messaging queues. So for example, when a record is newly inserted into the MDM, a message will be generated, and there will be consumers who will be listening to those queues. So if I have, for example, 3 consumers like source 1, source 2, and for example this is the source 3 data warehouse. So I will generate 3 message for every change. So these are the consumers who will be listening on those queues. So once any record is inserted into the MDM, message will be generated which will be consumed by them. So they will know that a new record has been inserted into the MDM, and they can process the data accordingly. So they can insert the data or they can update the data in their system. So basically MDM uses the messaging queues concept to communicate the changes that has happened into the MDM to the upstream and the downstream systems. So this is basically the MDM hub console, we say MDM tool or MDM hub console. So this was, I was talking about the configuration. So this is the configuration part, which is we usually called is an admin part. So we as a developer only takes care of this, because in this MDM it is the admin is not very vast as in like other things like Power Center or IDQ products Informatica has. It is not very vast, so this is taken care by the developers only. So we have this databases or the ORS, so where we create all the, basically register the ORS or the operational research stores here, and registering means it will get registered with the CMX system database. So once we register it, we will be able to use those. Similarly, we will be creating users here, that what are the users which are present, and those users will be assigned to which ORS. Similarly, we have tools access, which is, we can configure that which user is having access to which of the tools, and then other things like repository manager, which is used for promotion of the changes from one environment to the other environment. And then this is the model part, which is basically for the developers. So here we have this base objects. So we will create the base objects, the landing tables, and under the base objects we have all these stuffs like the staging tables that we configure, the staging tables, the relationships, the match and merge process. So everything is a configuration part only, and coding is not required as such in MDM. Just we have to do the configuration part. And once we configure all these things like creating the objects, the relationships, then we can go to the schema viewer, and here we can see the model. Basically it's a read only, and it just shows us that what are the base objects, or what are the tables, and what are the relationships between those tables. So that's the model part where all the development activities has to be done. Then we have the security access manager, where we configure all the roles and give access to the users. Like we will have different type of roles based on the business requirements, and there we basically give the access. So these are the access levels like read, create, update, delete, merge, and execute privileges, which has to be given on like column level basis. So once anyone fires a request, it comes to this MDM hub server, it will check the access, and if the user is having access, then it just pass the request to the client servers to process and return the results. Otherwise it will throw an error, and it will return the results back to the user that you don't have sufficient privileges to fire this request. So those are the security access manager. Then the data stewards section is there, where it is for the data stewards to log in and do some data manipulation activities, and then some utilities part. So this is the MDM Hub console. Then we have this IDD or Informatica Data Director, which is an external application which is provided with MDM itself, which comes with MDM, and it's basically an application where we uh, used to do all the data manipulation. Like from that application we can do all the steps like creating, updating, anything that is possible from here, because usually we don't give access to the MDM to other people. If anyone wants to view the data or access the data into the MDM, we give them the IDD application through them, and they can log into the IDD application, and based on whatever access we have provided, they can do all the steps there.
Vinay, just a small doubt.
Yes.
Here, data steward, as you said, like, is it for configuring a particular data steward, or is it where they actually do the updation or deletion, whatever that they do it?
Yes. Yeah, that is for the business users basically. The like there in the company we will have the BA business analysts, so who have the knowledge of the data. So it is referring to them basically. Like once a like when we run the match process basically. So and once it is matched, we will assign that match to a particular data steward or the business analyst. So he will look into that data, and if he feels that this is correct, he will merge those records. So data stewards are basically the business analysts who have the knowledge of the data.
Yeah, that is what. So they need to have this kind of whatever this application to themselves, so that they will do it from their end, or is it
Yes.
like a web application for them?
No, no, it's a web. IDD is a web application for them. So we don't give access to this MDM Hub console. we give access to the IDD basically. So they can log into the IDD, and based on these roles that we configure, they will be able to access the data. So for example, there might be a requirement that a particular data steward can only read the objects.
Okay.
He cannot create or update. So we will not give create update privileges. So he can just read the data, or he can, for example, update the data. He cannot create the data. So based on the business basically gives us this requirement, or it might be like one data steward is having access, all the access on only the address, because that data steward is basically specialist in address data. So I will give him only the access to the address. So the other data steward might be a specialist in all the customer data. So I can give him access only on the customer data, so that he can view the customer data and he can identify whether it is correct or not. So depending on the business, like how many data stewards the business wants to have and what level of access he wants to provide them. So based on that, we just give the access, and they will be able to log into the IDD and they can do all the changes.
Okay, fine.
Okay, thanks. So that's it from the MDM side. If you have any other questions, let me know.
So with this labs, we are going to have sample data that will be
Yes,
using
correct.
and moving through all the processes.
Yes, yes. Basically, this is the model that we will be working on. So sorry. This is the basically the model where we will have the customer address, and this is the model, and with this model I have the data also is present, so you can use that data to load it into the MDM. Sample data is available.
Okay. Okay. Okay.
And this is
And
basically the real time. Still,
go ahead. Go ahead.
sorry, can you come on?
How long does it take to complete this?
Yeah, it is basically 3 weeks period it takes. So if we are going to have daily classes like from Monday to Friday, we can expect it to get completed in 3 weeks period.
Okay.
Otherwise,
That's
sometime
very
if there is,
timely.
yeah, so if there is any delay, means maximum you can come with 1 month, because sometimes it happens that people are not able to come do the labs because so they need some more time. So in case we give a gap of 2-3 days, so it might extend for 1 month. Otherwise, it will get completed in 3 weeks period.
Okay. What's the mode of payment? I don't know if I need to ask the other people.
Yeah, because I am not sure. Mostly,
Yeah.
Ishwar will be there. I think he will be taking care.
Yeah, you are more technical. Okay.
Okay, so we'll end the session. It was nice having you in the demo, everyone.
Okay.
Thanks,
Thank you.
Vinay.
Okay, thanks. Bye, everyone.
Bye.